Hi, hello everyone. So this is the video dealing with section 1.6, transformations of functions, and this is the third part where we go over the next type of transformations, which are, or the last two types, which are the reflections and the dilations. So there's an issue with the dilations, and I am going to show you what they are here, but we're not going to do dilations in this part of the course. We're going to save them for later in the course when we talk about trigonometric functions, and you see why. So the reflection, so we begin with the reflection. So there's two types of reflections. Again, we can only do these transformations once we know how to graph uh, the common functions that we've covered in the first part of the video. Okay, so there are two types of reflections, a reflection on the x-axis, a reflection on the y-axis. Okay, so let's take a look here. And again, your textbook correctly uses the quadratic function, which is the easiest one to observe. We graph the quadratic function, which is the one in black, and we do a reflection on the x-axis. Now, what does that mean? So our x-axis is right here. So it's like you put a glass or a mirror right here on the x-axis and you see a reflection on the glass of the function. So the blue graph is the reflection on the x-axis. Okay? So reflection on the x-axis is done by, as you can see here, this is the basic function, and this is the reflected function. The reflection has a minus outside of the function box. All right, let's take a look at an example, and I'll tell you about the other reflection in a minute. So here's the function that we have to graph. I hope you can see here, there's a minus in front of the cubic root function. So we graph the cubic root function. This is the graph. Okay, again, we focus on a centerpiece, which is the origin again. And now we apply the transformation, which in this case is a reflection on the x. All right. So it's like you have a mirror again here. This piece will go down. This piece get reflected up. So we end up with this function right here. Notice that the reflection, the centerpiece where you're holding your function does not move, right? Didn't move in this particular case. All right, so a reflection on the x-axis, and now I'll summarize it at the end of the video, but a reflection on the x-axis is minus whatever the function is. So the minus is not inside of the function, it's outside. Okay? Now let's take a look at a reflection on the y-axis. So a reflection on the y-axis is obviously the same as before, but now your mirror is on the y-axis. So here's your mirror. So this piece gets reflected over here. Okay, so we would graph the standard function square root of x, and then we would reflect it on the y. Right? The centerpiece remains the same. Right, so notice how we differentiate one from the other. So here are the two reflections. The basic function, whatever it is, I'm going to call it f of x. And then I can have minus f of x, or I can have f of minus x. In this case, this is a reflection on the x-axis. The minus is outside. It's not affecting the function, the input of the function. In this case, The minus is inside the function. This is a reflection on the y-axis. Okay. The examples that you saw before, one was minus x squared, and the other one, this is a reflection on the x, and the other case was minus x. This is a reflection on the y. Just in case you want to, just for comparison purposes, a reflection on the x would be this. Okay. So your textbook probably should have used two identical functions so that you could see. So this is a reflection on the x because the minus is outside. This is a reflection on the y because the minus is inside of the function. All right, so these are the two reflections on the x and on the y. Now let's take a look at dilation. So as I said, I'm going to explain it to you what it is, but we're not going to graph them now because as you see here, it's almost impossible to see what a dilation is, even with software. So a dilation is nothing more than a stretch or a shrink of the parent function. Now, so take a look again, the quadratic. Our basic function is the black one. A dilation would be, so if my function is f of x, if I have a factor multiplying the f of x, this is called a dilation. This is a number, 2, 3, 4, 5, 6, 7, 10, or something smaller than 1, 1/2, 1/3, 2/3, and so on and so forth. If A is bigger than 1, we call it a stretch. If it is smaller than 1, but still positive, we call it a shrink. Okay? Now, so look again here on the basic case. I have a 2 multiplying the x squared. So the 2 is a stretch. And what does it do? It bends the curve more, or in other words, it grows faster, right? 2x squared grows faster than just x squared. So the curve seems to bend in forward. It grows faster. In the other scenario, I have a 1/2 here, and we have the reddish curve or graph. So this seems like it was pushed out and it is growing slower. Okay. Now I know that it's very confusing because it seems like this function is stretched and it looks stretched. It's pushed out, right? And it seems like this function here, the red one, is bigger than the black, which is exactly the opposite, right? So the black function is going to reach a particular point a lot sooner than the red one is. So, dilation on non-trigonometric functions is very complicated. So it's easy to see only on sine and cosine. So we're going to reserve the dilation for later in the course. But here's an example, right? So we have the cubic. So we graph the cubic, as you see right here, and then we apply the dilation, which in this case is a shrink, right, to 1/2. So this is the new, again, the dilation does not change the location of the key or the central point. But notice, it's almost impossible to see how they are different. So this is the basic graph. This is the shrinkage. It's difficult, right? Your textbook is using a point here to position yourself, but the point doesn't really help because our brains will go for the shape of the curve, which they look the same. So for the purposes of exam one, where we're going to cover the topic 1.6, we are not going to be doing dilation on polynomial functions. All right, so they're not very applicable, and we're only going to be doing dilation on the trigonometric functions of sine and cosine. So in this video, just focus on the reflection on the x-axis and reflection on the y-axis as I wrote over here.